Hello students! So this video here is part 3 of solving linear and nonlinear systems algebraically. Now, I was not planning for there to be a part 3, but seeing as to how we can't really control what technology issues we have, and my part 2 video just completely cut off because this school issued laptop decided to shut itself off, let's go ahead on and continue with this video here. With this lesson, and thankfully I did not completely lose part 2 video. Thankfully that was able to upload. But anyway, at the end of part 2, which happened unexpectedly, we had finished with example 2 of solving linear systems of equations using the elimination method, or again what's called the addition method. We're going to go ahead on and pick back up right there with example 3. Okay guys, so this is example 3 where we are using the elimination method or the addition method to solve these systems. Guys, remember with the first example we had two equations where the coefficients of one of the variables were already additive inverses or opposites, and in that first example all we had to do was literally just add the two equations together, and when we did that, immediately that one variable canceled out. In example 2, guys, we had it where the coefficients of one of the variables were set up so that one of those coefficients was a multiple of the other one. And in example 2, what we had to do was we had to multiply one of those equations times a constant factor, so that when we did that, so that when we added the two equations together, one of the variables cancels. This example is different from the first two because we don't have the coefficients of one of the variables as a multiple, and we don't have those coefficients of one of the variables where they're the same number but they're different signs. So with this one, guys, we need to kind of regroup, and we're actually going to have to multiply both equations here times a constant factor. So again, for this example, we're going to have to multiply both of our equations here times some constant factor. And guys, it may actually be a different constant factor for both equations. And so let's kind of talk about how we decide exactly what that constant factor is that we multiply each equation by. Okay, so guys, what we're going to do is we're going to choose one of these two variables to do this with, and guys, I'm going to choose y because y just so happens to have smaller coefficients. It has a 6 as a coefficient and a 14, and those coefficients are smaller than the coefficients for x. So I'm going to choose to use y because of that. And so, guys, what we want to do is we want to look at those coefficients for y, and you want to sort of think about the least common multiple. So guys, that's a term that you should have heard before. If not in Math 1, you should have heard it at some point in time in middle school, or in pre-algebra, whatever we call it. But anyway, least common multiple, you're going to identify the least common multiple of those two variables. Least common multiple. For those who don't remember what a least common multiple is, let me remind you with these two numbers. I apologize about the sloppiness of that here. Yeah. As long as you can still read it, that's all right. Okay. So let me remind you about what least common multiples are. So for instance, right, if we were doing multiples of 6, again we've got 6, 12, 18, 24, right? These are multiples of 6. In other words, if you're counting by 6, right, 6, 12, 18, 24, 30, I'm going to keep going for a little bit, not a whole lot. 30, 36, 42, 48, 54. I'm going to stop at 60 for now. Those are some multiples of 6. If we list out also some multiples of 14, if we're counting by 14, guys, if you don't know how to count by 14, get you a calculator. 14 times 1 is what? 14. 14 times 2 is what? 28. 14 times 3 is what? 42. 14 times 4 is what? 56. I'm going to stop there for now because we've got enough multiples listed where you can identify a least common multiple for these two numbers. We can identify a least common multiple for 6 and 14. So guys, out of these least common multiples out of these multiples that we have listed for these two numbers, again, we've got multiples of 6 listed, we've got multiples of 14 listed. And again, out of these multiples, you should be able to see a common multiple, and you should be able to see a least common multiple between them. So a multiple that they both have in common. And you should be able to tell exactly what the smallest multiple that they have in common is. And guys, if you're looking at what I'm looking at, that's the number 42. 42 is the least common multiple. So again, the first thing that you're going to do, and guys, the first thing that you're going to do is figure out what is the least. So you're going to choose which variable that you want to look at, and you're going to look at the coefficients for that variable, and you're going to identify the least common multiple for those coefficients. Guys, identifying that least common multiple is going to help us figure out what we need to multiply each equation by. Okay, so again, guys, we have just listed out those multiples of those two coefficients. So again, guys, we are identifying the least common multiple of those two coefficients. And again, the least common multiple for 6 and 14 is 14. So again, this is the first thing that you'll do for an example like this. The LCM is 42. So guys, the way that we're going to use that least common multiple for those two numbers is that we need to go ahead on and we need to think about, okay, what is it that we need to multiply each equation by in order for that 6 to become 42 and in order for that 14 to become 42. So in other words, guys, we're going to multiply both equations by some constant factor. And again, it might be a different constant factor, but we're going to multiply both equations by some constant factor so that the coefficients for the y, for that variable y, are both 42. So what multiplies times -6 to give us 42, and what multiplies times 14 to give us 42? Now, guys, if you listed out the multiples like what I'm showing you to do here, then you shouldn't have a problem with even if you don't really know your multiplication tables like that. If you listen out the multiples, you can count how many or what number times 6 gives you 42. You can count it with me. 1, 2, 3, 4, 5, 6, 7. 7 times 6 gives you 42. Because you listed out all of the multiples of 6 like I did here in this video, right? Okay, great. So we're going to multiply the first equation times 7. Not too hard, right? All right, and guys, what number multiplies times 14 to give us 42? Again, folks, if you listed out the multiples of 14, like I've done here in this video, then you can count it with me. 1, 2, 3. Look at that. 3 times 14 gives you 42. So we're going to multiply the second equation times 3. Alright, so again guys, we're going to multiply each equation by a constant factor. And again, that constant factor is more than likely going to be different for each equation. But again, folks, we're doing this so that those coefficients, that 6 and that 14, we're multiplying both equations so that those coefficients can actually match up, and so that they can both actually be the same value as that LCM that you've identified. Alright, so let's do that. Let's look at the first equation. What was that? 14x minus 6y equals 36. And again, we're multiplying that equation. And we've already kind of discussed how we determine exactly what number it is that we're multiplying by. Again, folks, the number that we need to multiply by there is 7. So that will be the same thing, so that the 6 there will turn into a 42. Again, the number that we need to multiply by is 7 for this first equation. And we need to multiply or distribute that 7 times each of those variables on both sides of the equation. Alright, and then for the second equation there that we've got, the 17, I'm going to break that up just a little bit. 17x plus 14y equals negative 84. Alright, so for that one, we need to multiply this equation by 3. Yeah. Yeah, okay. Yeah, this thing is messing my writing up. It's okay. Yeah, it did it again. Let's try it again. Come on. Alright, we're multiplying that second equation by 3. And we need to distribute each term in that equation by 3. It still did it again? Okay. Alright, so when we distribute into both of those equations, 7 times 14 is 98. 98x. 7 times 6 gives us 42. And guys, when we do this first equation, that's going to be negative 42 y. When we do the second equation, multiplying the 3 times 14, it'll give us positive 42. Again, guys, we want to make sure that when we do this multiplying for both of these, that again, we've got that LCM 42 for both of these, and we want to make sure that those 42s, that LCM has opposite signs in both equations. Alright, so again, for this first equation, that's negative 42y. And then when we multiply 7 times 36, we get 252. Alright, and then for the second equation, when we multiply 3 times 17, we get 51x. And then 3 times 14 gives us 42, positive 42y. Positive 42y. And then 3 times negative 84, that gives us, it's got to be negative 252 again. Three times negative 84 gives us negative 252. Alright, so we've got here, alright, we've multiplied both of these equations times that constant or times their constant factor, and at this point in time we've got it so that both of these coefficients, they are your LCM. They are the same thing as the least common multiple that we had, and they are opposite signs. You can see here that one of them is positive 42, the other one is negative 42, right? All right. So again, now that we've got that same number for this variable, but they're opposite signs, now we can add these two equations together. So that's what we're going to do. We're going to add these two equations together. And again, guys, remember that the goal for elimination method is to be able to add the two equations together so that that variable cancels out. So let's add these two equations together, and we're going to see that variable cancel out. Okay, so we are adding these two together. Let's see what that's going to look like. So we're adding plus. You guys get to see my ruler again. And goodbye ruler. Alright, so let's add together these like terms there. Or let's combine these like terms that are on the same side of the equation. 98 plus 51, that gives us 149. 149x. Yeah, I didn't want to write that in red. Let's switch that. I didn't want to write it in black. Okay. Alright. So let's see. 149x. Okay. When we're doing negative 42y and positive 42y, adding those or combining those two like terms cancels those out or eliminates that variable, which is exactly what we wanted it to do. Alright, so that variable is gone. Poof, be gone. Alright, next, the next like term is positive 252, negative 252. Alright, what happens when we do positive 252, negative 252? Oh snap. Oh snap, y'all. That cancels out too. Oh man. But what does it cancel out to? Oh my goodness. What do we get when we do 252 plus negative 252? It cancels out, but does it cancel out to some specific number? That's the question. And guys, yes, it does. It cancels out, but remember, guys, because those two are additive inverses, they cancel out. But remember that it gives us 0. 0, okay? And you got to put 0, okay? You are not done just because this number canceled out. Yes, it's okay for you to have 0 in an equation, all right? Yeah, okay. All right, next. We need to go ahead on and make sure that we solve for that variable. And again, guys, notice that now that we have added those two equations together, again, now we've eliminated one variable and there's only one variable remaining. So guys, let's go ahead on and solve for this variable. And we're going to do that by really the only step that we can take. Divide by 149 on both sides. Oh snap, y'all. Oh man, we got 0 divided by a number. Oh man. Y'all, can we divide 0 by a number? Man, I don't even know. I think, you know what, y'all? There was something about dividing with 0 that you guys should remember. But I'm going to go ahead on and quit playing around. Guys, we can divide 0 by a number. 0 divided by 149 is 0. what you guys might be remembering, and what you guys may be remembering is this here. If you had to divide a number by 0, in other words, if 0 was at the bottom of your fraction, then you cannot divide that, because that would be undefined. But guys, that's not what we have here. We don't have 0 at the bottom of this fraction. Okay? 0 is at the top of this fraction. So again, do not get that mixed up. Okay? It's only undefined when you have 0 at the bottom of your fraction. So again, here 0 is at the top of your fraction, which means we can divide here. And 0 divided by 149 gives us a number. And the result is 0. The quotient there is 0 when we divide that. All right, let me erase this part right here, because y'all don't need to see that no more. Yeah. All right. Okay, so we've got the value of x equals 0. By now, guys, you should know how what to do once we have found the value of one of our variables. You should know that we need to go ahead on and plug that number into one of our original equations. We need to plug that value into either one of the equations so that we can find the other variable. Alright, so let's go ahead on and do that. Let's substitute that value that we have for x into one of the original equations. And like I said, guys, it does not matter which one of the original equations you choose. I'm going to choose that first equation, not just because it's the first one I see in this case. I'm going to choose that first equation right now because it has smaller numbers in it. Okay. Alright, so let's see here. That first equation, 14, negative 6, 36. Alright, first equation, 14x minus 6y equals 36. Let's make sure I wrote that the right way. Don't want to have to come back and do that again. Yeah. 14x minus 6y equals 36. Alright. So, again, guys, we want to go ahead on and substitute that value. So, 0. We want to substitute that value in here for x. Alright. So, we want to plug that in right there for x. Oops. Okay. $14. Alright, so we still got the 14 there. We're going to replace that x with 0. This is still minus 6y, and this part here is equal to 36. Alright, so 14 times 0 is clearly 0, right? Because you multiply anything times 0, it gives you 0. You should kind of remember that, the 0 product. Alright, minus 6y, and that's something very basic anyway, right? Equals 36. Alright, now, did I have to write 0 minus 6y? No, right? I didn't have to write 0 minus that, because if I'm subtracting something from 0, guess what? It's just that thing. So we've just got here negative 6y. We don't have to write that 0 there. Negative 6y equals 36, and this is going to be the only step that we can take to solve that is dividing by negative 6 on both sides. Alright, so when we do that, we get y equals negative 6. Okay, guys, remember that we're not done here, because the way that we write our solution isn't just having an x value and having a y value. Remember that you've got to write that solution as an ordered pair. in the form of x, y as an ordered pair. With the parentheses, your x and your y, just like that right there. Alright, so that ordered pair is 0, -6. Alright, and that's the way the cookie crumbles right there. Okay, yeah, let's try that again. Good enough. Alright, guys, next we're going to just make sure that you know how to solve a non-linear system. And guys, the only way for you to solve, or the way that I'm showing you how to solve a non-linear system algebraically is using substitution. So again, that's what we're going to do here. Okay guys, before I show you again how to solve the nonlinear systems, there's one thing that I need to make sure that you know. This is FYI, for your information, very important, something that you need to know about these systems. There are 3 different types of systems. 3 different types of systems that based on the solutions. So there are different types of solutions that you'll have for systems, and these types of systems are called different things based on what kinds of solutions you're going to have, and based on the number of solutions that you'll have. Again, folks, there are 3 different types of systems based on the solutions. Guys, we say that a system is inconsistent if there is no solution. Guys, what that means, what that no solution means, is that there is no ordered pair in the form of x, y that satisfies all of the equations in the system. So again, if that's the case and you have no solution, then again that type of system is called technically inconsistent. Okay, and we can say that system is inconsistent if there is no solution. Guys, it's very important for you to know that after you have solved an equation, so let's say you were doing a problem and you were solving, you were trying to solve a system of equations, and you had gotten to the point where you were actually solving an equation, trying to find a variable, right? After solving, guys, an equation with no solution might look like this right here. You guys see what I got written down there? You see that? It might look like this. It might look something like -2 = 5. Well, guess what, guys? -2 is not actually equal to 5. Picture that. It might look like something like this. 0 is equal to 2. Well, guess what? 0 is not actually equal to 2, is it? But when you get finished solving or trying to solve for a variable, your equation might look like that. So guys, I've showed you another way that it may look. So let's say that you were solving or trying to solve for a variable, and let's say that you had gotten to a place where you had x plus 1 on one side of the equation, and you had x plus 2 on the other side of the equation, right? So let's say you had gotten down to that place, and you had an equation that said x plus 1 = x plus 2. So guys, if we were trying to solve that and we subtracted x from both sides, right? And we would do that anyway, trying to get all of the variables together on one side of the equation, right? So if we did that, subtracting x on both sides, guess what? Your variables would cancel out on both sides of the equation. And guys, if that happened, And if both of the variables canceled out on both sides of the equations, guess what? For this equation, we will be left with something like 1 equals 2. But guess what, y'all? 1 does not equal 2. So guys, this is what it boils down to. If you are trying to solve an equation and both of your variables cancel out, and if you, and I'll put it like this, if you get to a place in solving that equation where you know without a shadow of a doubt, you know unequivocally. Now, I'm sorry about using all these big words, but I'm smart. I'm sorry. I'm not apologizing for it. If you know unequivocally, without any doubts in your mind, indubitably, if you know that equation is not true, that is when you know, guys, that there is no solution. Okay? All right. So, guys, again, that first type was the first type of system based on solutions was inconsistent, and that was one where there's no solution. And again, I showed you how those equations might look if you had gotten to a place where you were trying to solve that system and your equation looked something like that, like what I showed you. The next type of system is consistent. And guys, there's actually two types of consistent systems, but again, this type here that we're talking about is consistent and independent. So, folks, we say that a system is consistent and independent if there is one or a specific finite number of solutions. Guys, what we mean when we say finite is, in other words, you can count a specific number. You can actually count how many solutions there are. So it is consistent and independent if there is one or a specific finite number of solutions. All right, and so guys, pretty much all of the examples that we have looked at for solving systems of equations up to this point have been consistent and independent. Where when we were solving those systems of equations, we got to a point in there where we literally solved the variable, like for instance, the equation might have looked like this: x equals 3. Ha, yeah. Like each equation that we have solved, each example that we've solved so far has looked like this, has been consistent and independent. Yes. All right, so it could look something like x equals 3 or something like y equals 5, right? Great. Awesome. Lovely. Next thing coming up, right, in just a moment. Okay, so guys, the third type of system based on the solutions. Again, guys, the second one was consistent and independent. This one is consistent and dependent. And we say that a system is consistent and dependent if there are infinitely many solutions. Guys, what that means is that, again, what infinitely many solutions means is that there are an infinite number, or in other words, there's an uncountable number of solutions. Now, guys, that doesn't mean that every single point on the coordinate plane is a solution. That's not what it means. But what it means is that those particular points that are solutions, there's so many of them that we can't really count it. So again, it's almost like, but anyway, I was gonna give you an analogy, but there's no point. There's no point because it's an uncountable number. Anyway, so consistent and dependable is only called or only known as consistent and dependent. I just said dependable, didn't I? Consistent and dependent if there is infinitely many solutions, which means pretty much that there's an infinite number or uncountable number of solutions. Guys, if you were solving a system of equation and your equation started to look like something like what you see here. So again, if your equation started to look like one of these things, if it started to look something like x equals x, right? Okay? Well, guess what, y'all? X is equal to x. That's very true. And x would be equal to x no matter what value of x you plugged in. Ain't that right? So despite any particular x value you plugged in, x would equal to x. All right, anyway, so if your equation started to look something like that, yeah, so you're not going to find any specific value for x, but again, your equation might look something like that, x equals x, or your equation could look something like this, 2 equals 2, all right? When you are solving that system of equation, and you get to a point in your equation may look something like 2 equals 2, right? Or, right, let's say that we were solving a system of equation, like, and let's say that our equation started to look something like this: negative x plus 2 minus 2 equals negative x, right? So what we would do to try to solve that is we would add x on both sides, right? So what would happen if we tried to add x on both sides of this equation? Well, our x's would cancel out on both sides of the equation, right? So it would cancel out on the left side. We would still have 2 minus 2 on the left side. And when it canceled out on the right side, that would leave us with 0 on the right side, right? Well, guess what? 2 minus 2 is equal to 0. And so, guys, for this equation, you know, it would end up looking something like 0 equals 0. So, guys, so whether your equation looked something like x equals x, 2 equals 2, or 0 equals 0, right? One way or another, you're unable to find a specific value for that variable. And, in other words, guys, when you're solving this equation, guys, you get to a place where you cannot solve any further, and this equation is true no matter what. X is always equal to x, 2 is always equal to 2, and 0 is always equal to 0. You can't solve any further, and this equation is true. So if you get to a place when you're trying to solve the system and it looks like that, guys, then, in other words, there is infinitely many solutions. All right, guys, now we're going to go ahead on and look at how to solve a nonlinear system of equations. And guys, we're going to look at a linear quadratic combination. In other words, where one equation is linear and one equation is quadratic. And I'm only going to show you this type because that's the only type that's in your practice on Delta Math. And again, guys, I'm talking to my students enrolled in my classes at our school. Don't make me say the name of the school, but you know who you are. You know what our school is. All right, so let's look at an example with a linear quadratic system. Again, folks, this is not the only type of non-linear system, but it's the only type that's involved for your practice on today's lesson. Okay, so for this example here, guys, again, notice how one of the equations is linear, one of the equations is quadratic. We are solving this using substitution or using the substitution method. Again, folks, if it is necessary, you will solve one of the equations for a variable. and then you will substitute the equivalent expression into the other equation. At this point in time, guys, you should be very familiar. If not experts, you should be very familiar with what we mean when we say use the substitution method. Again, in order to use that, one of the equations has to be solved for a variable. So if it is necessary, do that. Solve one of the equations for a variable if necessary. But again, folks, you should notice here by looking at these two equations that it is not necessary for us to do this in this particular example. It's not necessary for us to solve one of the equations for a variable because one of the equations is already solved for a variable. The first equation is already solved for a variable. So all we need to do here is we need to go ahead on and substitute that equivalent expression there into the other equation. The equivalent expression here is that expression negative x squared. Excuse me, give me one sec here. Is that expression negative x squared minus x plus 6. So again, that is the equivalent expression right here. I figured as much. Figured it wasn't going to do what I actually wanted it to do. Probably not going to do it here either. I'm surprised it did. Alright, so, and the other equation is x, oops, give me a sec here. The other equation is x minus y equals negative 3. So again, folks, here we want to substitute that equivalent expression, and again, it's an expression that's equivalent to y. We want to substitute that equivalent expression into the other equation, into this equation here. Alright, and so we plug that into this equation right here, and we plug it in for y. So when we do that, now we've got this equation x minus, instead of us writing y, we replace that. Again, we substitute it. We substitute in its place that equivalent expression, which is negative x squared minus x plus 6. And that's not the end of this equation that we're substituting it into. We still have the equals negative 3. And so, guys, now that we have substituted that particular expression into this equation, we notice that we've only got one variable left, and that's what we need to solve this equation. Look at that, y'all. This is a quadratic equation. We have talked about solving quadratic equations. Y'all, we did an entire unit on solving quadratic equations. You know how many different methods we talked about for solving quadratic equations? I mean, we really don't even have enough time to talk about all the different methods we talked about with solving quadratic equations. Factoring, solving by factoring, solving by using the quadratic formula, completing the square. I mean, solving by using square roots. We've done so many methods on solving quadratic equations that again, folks, doing this right here should be no problem. But before we look at solving this quadratic equation, let's simplify it here, okay? Here we're able to distribute this negative. Guys, remember that technically in front of that set of parentheses, right now we've got a negative 1. And if we distribute that negative 1 here inside of these parentheses, again, let's write the rest of this equation equals negative 3, and we still got the x here. But if we distribute that negative 1 on the inside of this parentheses here, that's going to end up being plus x squared. So that'll be plus x squared and plus x and minus 6. Alright, so guys, probably the easiest, or probably, well, yeah, I guess it's going to depend on which methods you really prefer. But again, folks, I'm going to remind you that if you were going to try to solve this quadratic equation by factoring, or solve this quadratic equation by using the quadratic formula, if you were going to use one of those two methods, and those are probably going to be the two easiest methods to try to use in this example, solving by factoring, solving by using the quadratic formula. If you were going to use one of those two methods, guys, you would need to have your equation set equal to 0, and you would need to have the equation written in standard form. You would have one side of the equation set equal to 0, and the other side of the equation would need to be in standard form if you were going to use one of those two methods. Alright, so again, folks, let's go ahead on and let's get this equation written or set equal to 0 on one side, and let's make sure that the expression on the other side is written in standard form. Standard form. Alright, so let's go ahead on and let's do that. Alright, so guys, to get this equation set equal to 0, we should all know exactly what to do there. There's only one number that's keeping this particular equation from being set equal to 0, and that is this -3. So to get this equation set equal to 0, we know what to do. We're going to add 3 to both sides right here. Let's add 3 to both sides of the equation. That's going to cancel that out, leave us with 0 on one side of the equation. Now on the left side of the equation, we've got all of these things. If we go ahead on and combine that -3 and the positive 3 and the -6, that gives us -3. Folks, if we want this expression on the left side or on the other side of the equation to be in standard form, we need to go ahead on and combine our like terms and make sure that again. Ooh, that's sloppy. It's alright. It's okay. It's gonna be alright. And make sure that it is written in that standard form for a quadratic equation. Remember, guys, standard form for quadratic equation is that form ax squared plus bx plus c. That form right there. Alright, so right now it's not that expression on the left side of the equation is not in that form. So let's combine these like terms and let's put them in the right order. Right? So let's put the x's together. Those two x's there that are like terms. When we put those two together, that makes that 2x, right? And then we've got the -3 here. Now all three of these terms are in the right order, and this is written in standard form. Now we can either solve by factoring, or we can do the quadratic formula. Guys, the easiest way probably is for those who know how to factor quadratic expressions, especially simple quadratic expressions like this one, where the a value is 1. The easiest way here is probably going to be to factor this. I'm going to show you this really quickly by factoring, because as you can see, it's very late, or depending on how you're looking at it, it's very early in the morning. But anyway, yeah. Alright, I'm going to write down what the quadratic formula is as a reminder to you, and if you need a reminder or a refresher about how to use the quadratic formula, then you can look up a video, or you can subscribe to my YouTube channel. You can look at those previous video lessons that we've talked about about solving quadratic equations. And again, you can kind of refresh yourself on that. Again, right now I'm just going to write down the quadratic formula for you here. And again, if you need a refresher on how to use that, feel free to look it up on your own, or look at some of those previous lessons that we've done, some of those previous videos that we've done showing you that. All right, negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so remember, that's the quadratic formula if you choose to use the quadratic formula to solve this quadratic equation. Wow, okay, yeah, a little bit better there. Alright, so again, guys, I'm going to solve this one here by factoring, because that's going to be the easiest way to do this right now. We find factors of c, so factors of -3, that constant term, find two factors of that add to the middle term, that add to that linear term, that middle term, 2. So we're looking for two factors of -3 that add to give us +2. Alright, those two factors of -3 that will add to give us +2 are 3. And again, guys, if you need a refresher on factoring quadratics, feel free to look that up on your own, or feel free to look back at some of the previous lessons that we've already gone over, some of the previous videos that we've already done, where we've done solving by factoring quadratic equations, or solving quadratic equations by factoring. Alright, so again, 3 and -1 are those two factors that add together to give us +2. So again, we found two factors of -3 that add together to give us +2. And guys, when we write out these two factors, remember that we write it out like this. And this is how we do it when that a value is 1. Again, when that leading coefficient is 1, this is how we do it. When it's factorable, this is how we do it. Alright, and remember, guys, this is still equal to 0. So those two factors there are x minus 1 and x plus 3. And remember, guys, if we use the zero product property, we set each one of these factors equal to 0. So we set the x minus 1 equal to 0, we set x plus 3 equal to 0, and we solve that. We solve each of these equations. Okay, so again, we set each factor to equal to 0, and we solve them. Okay, we should not have any troubles with solving that right there, because we know that we should add 1 to both sides for that first equation, and then that's going to leave us with x equals 1, and if we subtract 3 on both sides of the equations here, that's going to leave us with x equals -3. Remember, guys, most of the time, if not all of the time, when we're solving quadratic equations, usually we'll have two solutions. And again, guys, the only time that you will not have two solutions, really, especially if you were doing the quadratic formula, the only time that you're not going to have two solutions is if the discriminant is 0. If that number up under the square root for the quadratic formula, if that number up under the square root, the discriminant is 0. That's the only time that you're not going to have two solutions. And remember, guys, the real reason why you got two solutions is the same reason why there's a plus or minus symbol in that quadratic formula. Remember that plus or minus means that there are two versions of this answer. And so again, these are your two solutions for this particular quadratic equation. But remember, guys, since this is a system, listen, since this is a system, even though it's a nonlinear system, but it's a system nonetheless. we're not done. Because remember, solutions of systems are written as ordered pairs. So we've got two x values. So that means, guys, we've got two ordered pairs that should be written in the form of xy. So guys, we need to find out what our y values are for these two ordered pairs. So guys, yes, we've solved for x here, but we need to go ahead on and we need to find out what is the y values for these particular x values. Again, guys, we don't have a whole lot of time to waste. So I'm not gonna write down the particular steps that we're taking, because technically it's the same things that I've already written several times in part 1 of this video, part 2 of this video, and part 3 of this video. So again, just take what I'm saying here. Again, so we need to substitute these x values in, and guys, the easiest equation in this particular case for us to substitute this into is going to be that linear equation. Let me show you which one I'm talking about. If it will actually select this, where you can see which equation I'm talking about here. Okay, you can't see that right now because that stupid thing popped up. Let me select it so you can, hold on. Let me select that equation so you can see what I'm talking about here. So you can see exactly what I'm talking about. Alright, that equation right there, you see it? You see it selected? That one right there, that one. That's going to be the easiest equation because that's a linear equation. That's going to be the easiest equation for us to plug in these x values into in order for us to solve for the y values there. Alright, so again, guys, we want to go ahead on and substitute these x values that we just found into one of the equations. And like I said, guys, it's going to be easiest for us to substitute it into that linear equation. So we're going to substitute that value into that equation that was up there, x minus y equals -3. Let me make sure that that's the right one. Yes, x minus y equals -3. We're going to substitute that value, that x value, in here. Right? So, and we're going to do that for each of these values that we have found for x, so that we can find out what both of these ordered pairs are as the solutions for this system. Because again, guys, as I've mentioned repeatedly, solutions for system are going to be ordered pairs written in the form of xy. And here we've got two x values, which means that we should have two ordered pairs here as solutions. So we need to plug this in, plug in each x value here. Alright, so if we plug in the 1 as an x value here, that's 1 minus y equals -3. And if we solve for y, again, folks, this equation is very simple. I'm sorry about not showing all the work here, but if we solve for y, subtracting 1 on both sides, that'll be -4, and then divide by -1, that's going to be that y equals 4 for this one. And then if we substitute this x value here, -3 in there, that's -3 minus y equals -3. And then if we solve this equation, again, we add 3 to both sides. If we add 3 to both sides, this will it will wind up being 0 on the right side of the equation, and then we've got -y equals 0, and so -y or -1y equals 0, we would have to divide by -1. But again, if we divide 0 by -1, that means that y equals 0. Alright, So we've got two different x values, two different y values, right? Two different ordered pairs as our solutions. So here for this linear quadratic system, here we've got two solutions. And so guys, remember that I've told you how equations might look when there is no solution, and when it's inconsistent, when it's an inconsistent system and there's no solution. And the reason why I've mentioned that, guys, is because some of your Delta Math assignments are going to ask you about that. It's going to ask you specifically how many solutions there are, and you'll need to know what your equation looks like if there is no solution. So I've mentioned that, and I've shown you that for that particular reason. Okay, so I don't want y'all to think that I'm showing you something for no good reason, right? And besides, it's in this curriculum. My students who are enrolled in my classes. All right, so our solutions. Y'all thought I forgot, didn't you? Our solutions here. And there are two solutions in the form of xy. Two solutions. Excuse me, y'all. Hold on one sec. Two solutions here. Wow, that is the sloppiest two ever. But that's okay. Two solutions in that ordered pair form. Okay, for one of them, the x value is 1. The y value is 4. So that, oops, that ain't no 4. Hold on. Almost there, y'all. So that was the ordered pair 1, 4. And the other solution was the ordered pair of -3, 0. Okay. Alright guys, I hope this video has been helpful to you. I hope that you have gotten a lot out of it with solving systems of equations, both linear systems and nonlinear systems of equations, algebraically. Remember guys, algebraically means that you have to show your work. You need to have it written on paper, your handwritten work showing where you have used algebra. The same algebra that I'm showing you how to use in these videos. And you need to show your work for the practice assignment, algebraically. All right. Bye-bye now. See you later in a few hours, I hope. Bye-bye. Good night.